All right. We are going to do Module 11, Section 2 for Math 1 Honors. And I know that you guys are anxious to get out of school and be done, but Module 11 is really important to make sure that you are really fluid with radicals and exponents so that when you get into Math 2 honors, that's just going to be easy for you. So make sure you just hang in there for Module 11 and then you'll be done. So, all right, let's get started. So 11.2, we'll just read the scenario. Carlos and Clarita, the Martinez twins, have run a summer business every year for the past 5 years. Their first business, a neighborhood lemonade stand, earned a small profit that their father insisted they deposit in a savings account at the local bank. So when the Martinez family moved a few months later, the twins decided to leave the money in the bank where it has been earning 5% interest annually. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. So remember how Dad said we could withdraw this money, like take it out of the bank when we are 20 years old? We have $382.88 in the account now. I wonder how much that'll be in 5 years from now. So given the facts listed above, how can the twins figure out how much the account will be worth 5 years from now when they are 20 years old? Well, 5% interest annually is actually converted to 1.05, right? Because if they want to figure out how much money they're going to have, it's like 100% of the money they have plus 5%. So you would just, doesn't it make sense that you would just multiply the starting balance by 1.05 5 times, which if you're going to multiply something by 5, something by a number 5 times, it's really like 1.05 the fifth power. So $382.88, which is their starting balance, times 1.05 to the fifth power is about $488.66. So Carlos calculates the value of the account 1 year at a time. He has just finished calculating the value of the account for the first 4 years. Describe how he can find the next year's balance and record that value in the table. So he's basically thinking about it in a recursive way, like what he needs to know the previous year to get the next year and so forth. So that's sort of how he's thinking about it. So he's basically saying, okay, we start with this much. I'm going to multiply it by 1.05, and then I'm going to get that amount. And then I'm going to multiply that by 1.05, and then I'm going to get that amount, and so forth. So this is sort of how he's thinking about it. So to get the next one, for the 5 years, he would just need, since he's thinking about it recursively, he would need the previous year, which is here. So 465.39 times 1.05, which is about 488.66. So 488.66. Okay, and it says describe how he can find the next year's balance. So basically, that's what he's doing. Multiply previous year by 1.05. Okay, so Clarita thinks Carlos is silly calculating the value of the account 1 year at a time and says that he could have written a formula, like an equation, for the nth year and then evaluate his formula when n equals 5. So write Clarita's formula for the nth year and use it to find the account balance at the end of the year 5. Okay, so basically she's saying don't think about it recursively, write an explicit formula. That makes sense, right? So she's saying for any given year, you have your starting balance, 382.88 times 1.05 to the nth year. So whatever that is. So we actually did that up here, and we got the same amount that he got. All right, so Carlos was surprised that Clarita's formula gave the same account balance as his year-by-year strategy. Explain in a way that would convince Carlos why this is so. Well, Carlos's way, basically is 1.05 times 1.05 times 1.05 times 1.05 times 1.05. And Clarita's way is saying, well, that's the same thing as 1.05 to the 5th power. So basically, he's thinking about it recursively, and she's thinking about it explicitly. So I can't remember how much money we earned that summer, said Carlos, that first summer. I wonder if we can figure out how much we deposited in the account 5 years ago, knowing the account balance now, because this is where they're at now, right? But they're saying they got to that place because they earned money 5 years ago and it's been earning interest. So how can I figure out, what we started with? So Carlos continued to use his strategy to extend his table year by year back 5 years ago. Explain what you think Carlos is doing to find his table values 1 year at a time, and continue filling in the table until you get to year -5, which Carlos used to represent 5 years ago. So, if he was multiplying each year by 1.05, then he's probably dividing each year by 1.05. So if you're going this way, you're dividing by 1.05 and then again and again and again. So if he divides this by 1.05, he ends up with about 347.28, and then he divides this by 1.05 and gets about 330.75, and then he divides this by 1.05 and gets about 314.99, which is about 315. And then he divides this by 1.05 and gets 300. So they started with $300 5 years ago. So Clarita evaluated her formula. Remember her explicit formula that she came up with before? So she evaluated her formula for n equals -5. So again, Carlos is surprised that they get the same results, and explain why Clarita's method works, but we'll just show it with math. So hers was f of n, but she's going to use f of -5 equals 382.88 times 1.05 to -5. So you think, how can I figure out what that amount is? But remember, if you have a negative exponent, it's the same thing as putting it in the other part of the fraction and making it positive. So really, what this is 382.88 times 1 over 1.05 to the 5th power. That's what that really is. Okay, so if you figure out what this is to the 5th power, and then divide 1 by that and multiply it, she ends up getting about $300 also. So 5 years ago, $300. Okay. because you can kind of use this to help you evaluate that if you have a negative exponent. So Clarita doesn't think leaving the money in the bank for another 5 years is such a great idea and suggests that they invest the money in their summer business, Curbside Rivalry, which for now they are keeping top secret from everyone, including their friends. I don't know why that they put that in there. Okay, anyway, we'll have some startup costs, and this will pay for them without having to withdraw money from our other account. And Carlos remarked, but we'll be withdrawing our money halfway through the year. So do you think we'll lose out on this year's interest? And she says, no, they'll pay us the half-year portion of our interest. But how much will that be? Asked Carlos. So calculate the account balance. How much interest do you think Carlos and Clarita should be paid? How much just interest? You think they should be paid if they withdraw their money one half a year from now. So remember, they currently have $382.88 in the account, and that they earn 5% annually. And then describe your strategy. Okay, well, why don't we just use Clarita's formula? So F of 1/2. So we have 382.88 times 1.05 to the 1/2. So you think, well, how do I figure out this? I mean, you could put that in a calculator as 1.05 to the 0.5 power. But remember, this is the same thing as this, right? Because you have this rule, a to the m over n equals a, so nth root n, or even you can think of it like this, which is the situation that we have. Okay, so here's another rule that we're going to use. Practice using radical rules. All right, so we're going to do 382.88. And then I found the square root of 1.05 is about 1.024. And so this is about $392.34. But remember, it just asked for their interest. So this would be the balance after half a year. But their interest, the interest is this total, 392.34, minus the balance that they had, 382.88. And so their interest is about, I think it's like $9 or something. So 392.34 minus 382.88. So the interest is about $9.46. That's how much the interest is. All right. So Carlos used the following strategy. He calculated how much interest they should be paid for a full year and then found half of that and then added that amount to the current balance. So Clarita used this strategy. She substituted 1/2 for n in her formula and recorded this as the account balance. So this time, Carlos and Clarita didn't get the same result. So whose method do you agree with and why? Okay, so let's look at what Carlos gets with his method. So basically he's saying, okay, I'm going to take 382.88. I'm going to multiply it by 1.05. And I'm going to add 382.88 and then divide it by 2. So he's saying, okay, I'm going to take this is like my interest, plus my balance, I'm going to divide it by 2, and he ends up getting about 392.45. This is balance, right? And then the interest he would get would be, basically the only interest. So I guess maybe he could just figure out this interest divided by 2. But I just did the whole thing and then I'm just going to subtract. So 392.45 minus 382.88. And so his interest is $9.57. Okay, let's look at Clarita's though. Remember, Clarita actually used her formula. 382.88 times 1.05 to the 1/2. Remember, and we just did this, and she got 392.34 for the balance, and so her interest was 946. So why is it that all their other methods worked and they got the same answer, but then this time it's not? Well, it's because Carlos is thinking about it linearly, and Clarita is thinking about it exponentially. So which method would you agree with and why? So I think I would agree with Clarita's method because this idea of multiplying by the same number over and over again, like a constant multiplier, is exponential. So I agree with Clarita. Because interest is an exponential relationship. So we're going to practice with these exponent rules. Hopefully you feel really comfortable with them. And so we're going to simplify each of the following expressions as much as possible and leave your answers with positive exponents only. So you never want to leave your answer to an exponent problem or a problem like this with a negative exponent. The only time you leave an answer with negative exponents is when you have scientific notation. So I'm going to go ahead and, you might want to just like pause the video right now and try these on your own, and then you can check and see if you get the right answer. So there's a bunch of different ways that you can go about doing these problems. So I'm going to do it my way, and then as long as you might do it in a different order, but as long as we get the same answer, then you're good. So I think you should pause right now. Try to do these problems on your own. This one's kind of hard to read down here. This is 16x to the negative 8. So I'm going to actually do these in a notebook because this is so tiny, it's really hard to read. So I'm going to copy the problems and then do them in a notebook. Okay. All right. So our first one is negative 3, x to the 7th, y to the 3rd squared, times 4x to the 6th, y to the 4th. And so this exponent needs to sort of be distributed to everything here. So negative 3 squared is 9. This is x to the 7 times 2, 14, y to the 6th, right, because you multiply. And then you have times 4x to the 6th, y to the 4th. And so now when you're multiplying with the same base, you add exponents. So I have 9 times 4, 36. And then I have x to the 14 plus 6, which is 20. And y to the 6 plus 4, which is 10. So this is the answer you should get for number 9. I'll remember them the way that they were. Okay, number 10 is 12x to the 9th, y to the negative 4, times 2x to the 5th, y to the 7th to the negative 1. So you should be remembering, actually, you should be bringing fond memories of B Honors, because in B Honors, we went through this all problems like this. So, okay, so remember, if you have a negative exponent, you need to put it in the bottom. Well, this negative 1 belongs only to this. So I'm just going to write, I'm going to think about like what goes on the top, what goes on the bottom. So 12x to the 9th. And then I'm going to leave this, I'm going to take this y to the negative 4 and put it on the bottom. Make it positive. Right? Let's put it on the bottom. And then all of this second term goes on the bottom because it's all taken to the negative 1. So this is going to be like times 2 to the 1, x to the 5, y to the 7. All right, and then I can just figure out what I have on top and bottom. So the 12 and the 2 simplifies to 6. And I have 9 x's on the top, 5 on the bottom, so I have 4 more on the top. And then the y's are only on the bottom, so I have y to the 11. So this is the answer you should have. Okay, 11. So 11 is 8 x to the 6th, y to the 13th, and then it's taken to the 1/2. Okay, this is where we didn't do these rational exponents in the honors. So you got to think about the rules, and I would change this to radicals, or you can actually work with it right now and then change it. So, I mean, this is basically 8 to the 1/2, x to the 3, right? Because you multiply powers by powers. And then it gets a little tricky when you have like y to the 13 over 2, right? So I would just change these. Like sometimes it's helpful to have an exponential form, sometimes it's helpful to have it in radical form. I think in this case, it's helpful to have it in radical form. So I really have square root of 8 times uh, maybe I shouldn't do that. Maybe I'll leave this like 6 over 2 so I can have all square roots. Okay, so I have square root of x to the 6th times square root of y to the 13th. So you know that the square root of 8 is actually square root of 8 is actually 2 radical 2. And then here I can take out 3 pairs of 2 x's at a time. So I have x to the 3rd times. And then how many pairs can I take out of 13? Well, I can take out 6 pairs out of 13. And then I have radical y, right? Because I have 6 pairs and then the leftover. Okay, so now I can just multiply whatever's on the outside with what's on the outside, whatever's on the inside with whatever's on the inside. So I have 2x to the 3rd, y to the 6th, and then these are both square roots, and then radical to y. Okay, so this should be your answer for number 11. And you might have just done it a different way. It's okay, as long as you get the same answer. Okay, number 12 is really hard to read on that original form. So it's 18x squared y to the negative 4 over 30 x to the negative 5 y to the negative 6 times 6x to the 7 y to the negative 4. All right, so you might do things in a different order than I do, but I like to get rid of all my negative exponents first. So I always think about like what goes on the top, what goes on the bottom, and then start simplifying. So 18 and 30 can simplify to 9 over 15 or 3 over 10. Actually, 3 over 10. Right? 6 goes into, oh wait, 5. Right? Because 6 goes into 18 3 times, goes into 35. Okay, this x squared stays on the top because it's positive. This y goes down to the bottom, y to the first. And then this x is going to go to the top to become positive. And this y is going to go to the top to become positive. And then I have the 6 over here, so that's in the top already. X to the 7, still in the top. This y is going to move to the bottom to become positive. All right, so now I have 3 times 6 over 5. So I have 18 on the top, 5 in the bottom. And then in the top, I have 7 x's plus 7 more, so it's x to the 14. And then in the bottom I have y, I have 7 y's, and in the top I have 6 y's. So I have one more y in the bottom, so it's just going to stay there. And you might, like I said, go about it a different way. That's just the way that I did it. Okay, 13 is 5x to the 0, y to the negative 8 over 30 x to the negative 3, y to the negative 2. All right, again, I like to get all my negatives where they need to go. Okay, 5 and 30 is 1/6. 5/30 is 1/6. And then x to the 0 is just 1. So it's like I just don't even need to think about it. And then this y is going to go to the bottom to become positive. This x is going to go to the top to become positive. This y is going to go to the top to become positive. So I end up with, I have 8 y's in the bottom and 2 in the top. So that means I have 6 more in the bottom. So I have x to the 3rd over 6 y to the 6th. All right. This last one was really hard to read, I think, on the first in the paper that I showed you before. So 28 x to the 4th, y to the negative 5 over 16 x to the negative 8, y to the negative 12. And then this whole thing is taken to the second power. So I think what I'll do is just sort of simplify inside, and then I'll apply this to later. Okay, so 28 over 16 is 7 over 4. And then I have this x to the 4th in the top. This x to the 8, negative 8 is going to go to the top to become positive. This y is going to come to the bottom to become positive. And this y is going to go to the top to become positive. And that's all split. So I have to square everything. I could simplify it first, but I think I'll do that. So I have 7x to the 12, and then I have 5 more y's in the top, so 5. Oops, I mean 7 more. I have 5 in the bottom, 7. And then in the bottom I have 4, and then put that 6. All right, so 7 squared, 49. 4 squared, 16. And then you're going to multiply these. So x to the 12 to 2 is x to the 24. Y to the 7th squared is y to the 14. And that's it. Okay, so hopefully you were able to get the same answers. Those are all based on, I don't know if Mr. Jenkins shared these rules with you, but you need to know all of these exponent rules. Like a to the n times a to the m equals a to the nm, and a to the n over a to the m equals a to the n minus m, and then a to the n m equals a to the n m. Like, you should know all of these rules actually from Be Honest, all these exponent rules. And then a to the negative n equals 1 over a to the n. And then, so these are all the rules actually that you learned in Be Honest. So you should know all of these rules. Okay, and then the new rules that you have for this year is changing between exponent notation and radical notation. So you have a rational exponent, like a fractional exponent. Then this becomes, like, the bottom number becomes the index, and the top number becomes the exponent, which is the same thing as this. So those are the same thing. And those are sort of the new rules. Oh, another rule that you knew from Be Honest is if you had like a over b to the n power, it's like a to the n over b. Okay. All right. Well, I hope that you got all those right. And if you didn't, just look through my work and try to figure out where you went wrong. Okay. We'll see you for 11.3 later. Hope you guys have a good day.